Hi, and welcome to your video lesson for Lesson 26, Solving Rational Equations. Right? So we're solving rational equations. What that means is that we're dealing with equations that have fractions in them, and particularly fractions in our denominator. We won't start with that. We'll work our way towards that, but that's what makes something, or rather an equation, rational, is that there is normally going to be a variable in the denominator of a fraction. That's what makes a rational function a rational function, is that you have some sort of a variable in your denominator. So we're going to have to recall a lot of our fraction rules in order to do this. So let's go ahead and recall one right now. We'll jump right into it and solve number one right here. So normally, right, you would want to have a common denominator here, right? So we could find a common denominator for these by just multiplying everything by, right, so if I was to find a common denominator for this, right, our common denominator would be 6, which would mean that I'd have to multiply this by 3 over 3. I would have to multiply this one by, I'd have to multiply the 1/3 by 2 over 2, right? And then I would just leave this alone, yeah? Which would give me 3x over 6 plus 2 of 6 equals 5, 6, right? And then I could add and subtract things from both sides and divide. But I'm going to show you that there is actually a much quicker way to do this. It turns out that if I was to just multiply everything by 6, that will also make all of my denominators go away, which will mean that I won't have to do really very much work with these fractions. So let's look at the other opportunity that we have here. So what if I was just to multiply everything by 6? So I have 6 times x over 2 plus 6 times 1/3 equals 6 times 5, 6, right? And I'm still within all of the rules of algebra because I multiplied 6 times everything in my equation. So what happens here? I'm just going to go ahead and take the extra step, right? I have 6x over 2. If I multiply that, because that's like 6 over 1. It's like each of these is 6 over 1. So I multiply the 6 times the x, and I get 6x. And I multiply the 1 times 2, and I get 2. Right? And I'll do the same thing with this one. I went with 6 times 1 is 6, and 1 times 3 is 3, equals, and then 6 times 5 is 30 over 6. And now I can simplify these fractions, right? 6 over 2, same thing as 6 divided by 2, that's 3x, and 6 over 3 is 2. And 30 divided by 6 is 5, and now I can just solve this thing really simply. Subtract 2 from both sides, and I get 3 here. So x is 1. Not too bad. We'll be able to get really fast at these to where we can actually skip some steps. So let's try this other one. So it looks pretty obvious that what I should do right here is just multiply everything by 9, right? So, and I could write it like this too. I could say, hey, I'm going to multiply this whole equation by 9. What's that going to do? It's going to make all of my denominators cancel out. So if I multiply that by 9, the same thing that happened in the previous equation is going to happen here. It's just that we can write in a lot less steps if we were to write it like that. So we realize that our denominators cancel, and since all of our denominators were the same, we wind up not multiplying our numerators, right? Because if I was to multiply that, I would wind up with 9 over 9 in each of those terms. So then I just subtract 5 from both sides, and I get that 2x is equal to 3. So x is going to be 3 halves. All right, so let's take this to the next level with this next example. All right, so if I had to pick a common denominator for these two, right, my common denominator would be 12, right? So it seems then that if I was to multiply, I'm just going to go ahead and rewrite this over here. If I was to multiply both sides by 12, I should be able to get rid of my denominators, right? So if I multiply this times 12, I know a lot of people will tell you these cancel, right? But really what's going on is that this is 1, right? I have a 12 over 12. So a lot of teachers will tell you, hey, the 12s cancel. But just keep in mind, yeah, they do go away. But really what happens is that is 1, right? 12 divided by 12 is 1. So I have actually 1 times x plus 3, which means that all I'm going to have left here is the x plus 3. Over here, I wind up with I'm gonna do the shortcut method of doing this, right? Where you see that what I have here, that these two here, isn't that 12 divided by 6, which is 2, right? So that means that I could just multiply my numerator by 2. All right, that's the shortcut. You might want to have a look at it and say, hey, this thing actually becomes, what is 5 times 12? 60 over 6. My bad, that's a 0. Which is 10, okay? So that's kind of the in-between step there to see what's going on. All right, if I'm to multiply by 6 times 12, I wind up with 60 over 6, which turns out to be 10, all right? Which is what I got right here. Okay, so now I subtract 3 from both sides, and I get the next step. Okay, let's move right along and try some more of these. Ooh, they're getting ever more complicated, aren't they? Okay, so when we have these truly rational equations, right, where we have a variable in our denominator, again, we're going to do the same thing we did before. We're going to find a common denominator. But this time, it's going to be a little different, right? So just real quick, imagine that instead of an x in our denominator, we had a 2. And say we needed to add these two things. Let's pretend that we had to add 3 halves and 8 thirds, right? So what is the common denominator, right? The greatest or rather the least common multiple of these two, right? So our greatest common denominator, we might even say our least common multiple, right? That's going to be 6. So that means that I would have to multiply this one times 3 over 3 and this one times 2 over 2, right? In order to work that out. And then I would wind up with 9, 6 plus 16, 6. And it all works out. Well, we're kind of doing the same thing with this one, right? What did we do with this one? Our greatest common divisor was 2 times 3, or if you look at it, there's our 2 times 3. So what's our greatest common divisor going to be for this one? Well, it's going to be x times x minus 2, right? In the same way that our greatest common divisor, our greatest common denominator is 2 times 3. And actually, if we can, let's just switch this up a little bit because your calculator does say GCD. So let's just call it a common denominator, okay? So let's go ahead and call this the common denominator, which is actually our least common multiple. Alright, so once we've decided what our common denominator is here, we're going to go ahead and multiply both sides by our common denominator. So in other words, I'm going to multiply this one by x times x minus 2, right, that side, and then this side is also going to be multiplied by x times x minus 2, right? Well, what happens if I multiply this, right? What I have is 3 times x times x minus 2 in my numerator. And in my denominator, I just wind up with x, right? Over here, I would have 8 times x minus 2 in my numerator, and my denominator would be x minus 2. But what goes on? Here, I have 1, right? So those are going to cancel. And over here, these are also just 1. So those are going to cancel out. So what I have left is 3 times x minus 2 on my left-hand side. And on my right-hand side, I'm left with 8x. And it becomes much simpler, right? I used to have a teacher that would tell me that mathematicians are lazy, right? They would like to take an easy problem, or harder problem, right, and make it easy by using some trick. And so the trick we're using is we're multiplying both sides by our common denominator, and that gives us something that is so much better to solve, right? It takes us right back to Algebra 1, where life was good, we were happy, equations were easy to solve, right? I subtract 3x from both sides, and I get negative 6 is equal to 5x. And when I divide both sides by 5, I get that x is equal to negative 6/5, right? And really, I mean, that's not laziness, that's just being efficient, right? That's just figuring out what the trick is, right? If you figure out what the trick is, life is so much easier in so many different ways, right? Okay. Oi! Who'd you call lazy? Why are you trying to call me lazy? I'm a mathematician. Scotty, take it easy, all right? You're not lazy. I understand you just want to do things efficiently. It's okay. Well, you better say you're sorry, because I'm not lazy. As a matter of fact, I'm so motivated. I'd like to solve the next problem if I could. Okay, Scotty, go for it. Just take it away. Do it. Okay, so first things first. I've got to find what my common denominator is, right? What's it going to be? Well, if I look at all of these things, I got to see if there are any similarities, right? So I've got 1 over a plus 2. And then I've got 1 over a minus 2. Right? And then I happen to be a little bit tricky. And I saw that what I've got right there is a difference of squares. It is. So it turns out that if I was to factor that, it turns out to be a minus 2 times a plus 2. And a lot of times, kids, that's what you'll find is your trick. Sometimes if you factor it, you'll find your common denominator right away. It turns out that our common denominator is going to be a minus 2 times a plus 2. Right? And it makes sense because I've got one of them here and I've got one of them there. So if I used to multiply both sides by a minus 2 times a plus 2, it should look a bit like this. Okay, so I've got an a minus 2 times a plus 2 times 1 over a plus 2 plus a minus 2 times a plus 2 times 1 over a minus 2 is equal to 4 over a minus 2 times a plus 2 times a minus 2 times a plus 2. It's a lot of writing it is. But look at how fancy I am. Okay, what you've got to realize is that we're going to cancel out a lot of things. Right, we've got a lot of ones all around. For instance, I've got one right here. Right, so those are going to go away. I've got one here, these two. They're going to cancel because they're 1. A minus 2 over a minus 2 is 1. And then look at this, all this is cancelling out. So let's look at the equation what I've got left. Alright, a minus 2 times 1 is going to be a minus 2 plus a plus 2 times 1, which is a plus 2 equals 4. Well, that's easy to solve. Look at it. I've just got to combine some like terms. Right? These 2's cancel, right? Because negative 2 plus 2 is 0. And then what I got to do, a plus a is going to give me 2a equals 4. And then I just divide both two sides by 2. And I get that a is equal to 2. And that was pretty easy, right? But I've got to be a wee bit careful. Okay? Because this is my answer. But there's a chance that it doesn't work. And if it doesn't work in one of my equations, then it's what we call extraneous. I'm going to write that down because my accent's real bad. So I would call it extraneous. Don't know how to spell. I didn't pass them classes, but I was real good at my math. But I think it's spelled like this. Oh, it is. Thank you, Mr. Dorman, for pointing that out to me. Okay, so what would it mean for this to be extraneous? Well, it turns out that, remember, you can't never do this. If you do it, you're not right. As a matter of fact, not only are you not right, but you're wrong too. So, if I wind up with this, that's what's going on. I'm calling it extraneous. So, I've got to go back in and plug that into my previous equations. So look at it. What happens if I was to plug it in right there? Wouldn't I wind up dividing by 0? So that gives me a situation where I'm dividing by 0. So I'm going to say that even though when I solved it, everything came out nice, it's going to be an extraneous solution. We should check back up here and see if Mr. Dorman didn't make a mistake. Is it the case that if I was to plug in x equals negative 6/5 either in here or in here, would I wind up dividing by 0? Well, I wouldn't. I wouldn't divide by 0. So it's okay, we'll keep it. It's going to be okay. It's not extraneous. Right? Extraneous. That's what we call it. Alright, well, I'm tired of this. I'm going to go take care of my land. Because they'll never take my land from me. Never. Okay, well, that's great, Scotty. Go take care of your land. Alright. Cool. Well, that was awesome. So anyhow, let's continue on and do another one of these. That one was about as complicated as they're gonna get. Alright, we'll get lots of practice with those as well. But always check for extraneous solutions. So here we go. Are we even asked? We weren't even asked for that in 4, but Scotty's a good guy. He picks it out. He's a very competent mathematician. So the first thing we need to do with this one is we need to figure out, hey, what is our common denominator here? All right? Well, it looks like these two share an x, right? So be careful. Don't choose x squared for this one, right? We're going to go ahead and choose, I think 12x would be the one to go with, right? 12x. Why? Because 12x is divisible by 3x. It's divisible by 4, and it's also divisible by x, right? So that's why that works. So I'm going to go ahead and multiply every one of these terms by 12x. All right, and let's see what happens. All right, 12 times 4 is 48, x over 3x. And occasionally, you know, sometimes I'll take the extra steps, sometimes not. I'm going to go ahead and just multiply these out. We have 3 terms, so I don't want it to get too messy. And here we wind up with 36 x over x. All right. So right here, we've got some x's that cancel, right? And then 48 divided by 3 is what? 16? And then my x is going to stay here because I don't have one in my denominator, right? So 60 divided by 4 gives me 15. And I still have the x. And then over here, these x's are also going to cancel, and I wind up with 36. All right, I'll subtract 16 from both sides, and that's going to make me land up. Just kidding. It'll make me end up with 20. And then I'll divide both sides by 15. I wind up with 20 15ths, which is the same as 4/3. And there it is. All right. Whew, we got lots and lots and lots of good examples here. All right, so again, like Scotty was saying, sometimes there's a trick, right? This is difference of squares, right? Which means that I can factor this. My bad. Whew, means I can factor this in this way, difference of squares, right? And look at that. That right there, same as that. B plus 3, also right there, right? So that must mean that my common denominator is actually b minus 3 times b plus 3. That's awesome. Fantastic. Okay, so check it out. I'm going to skip a little first step, and let's see if you guys feel comfortable with that, right? I know that if I multiply this times this, right, my b plus 3s are going to just cancel, yeah? So why not just go ahead and leave it out in the first place, right? So what I'm going to do then is, right, this is, so I'm actually multiplying both sides by b minus 3 times b plus 3. But every single time you do that, you're going to see that it's just going to make your denominator go away. And the term that's different, right, this is different from that, right, is the only thing that's going to be left. So then what I'll have here is 5 times b plus 3 equal to 10b minus 2. Because remember, if I was to multiply this by this quantity, right, if I was to multiply, they're just going to cancel out. So when you get to realize that, it saves you a bunch of time and writing. So now what I need to do is distribute, okay? 7b, 7 times b is 7b. 7 times negative 3 is negative 21. 5 times b is 5b. And 5 times 3 is 15. Now, I've got a little algebra 1 equation to solve, right? No problem. First thing I need to do is combine like terms. Please, please, don't try to add and subtract things from both sides yet. Let's make sure that we combine like terms first, all right? So 7b plus 5b gives me 13b. And negative 21 plus 15 is going to be negative 6. Now that we've combined like terms, we can go ahead and add and subtract stuff from both sides. So I like to keep my variables positive, and that's why I'm going to choose to subtract 10b from both sides first. Alright, so that's going to give me 3b minus 6 equals negative 2. And then I'll add 6 both sides. I'm just going to go ahead and write this over here. I'll rewrite the equation since I'm moving it over. Alright, I'm going to add 6 to both sides. And divide both sides by 3. And there we go. Alright, is there any way that I could get an extraneous solution if I plug that in for any of these b's? Well, I get 0. If I plug that into any of these, no. It's good. So it checks out. Let's make sure I put a check mark next to them. And just real quick, I'm going to go back. I'm not sure that I remember going over the extraneous solutions for this one. Is there any way that I could get 0 if I plugged 4/3 into this x or this x? Absolutely not, so it checks off. And just don't forget to put a little check mark there to show that you did check for extraneous solutions. It's a good way to keep track of that and check yourself before you wreck yourself. All right. Let's do another one. Again, usually the trick with these is to factor. Okay, it turns out that this does factor, right? I can find two numbers that if I multiply them, I get 12. And if I add them, I get negative 8. That would be negative 6 and negative 2. Funny. Isn't it crazy? The answer was located right there. So keep an eye out for that, okay, when you're trying to factor those. So what does that mean? That means that that is my common denominator. So I'll go ahead and use my trick where I know that my x minus 6's are going to cancel here with this thing, right? I'll wind up with x minus 6's canceling. So all I'll have on the numerator here is going to be x minus 2 times 1, right? But that's not going to change it. However, here I'll have x times x minus 6, right? And over here, our denominator will cancel. All right, so I will go ahead and distribute this x. I get x squared, and then minus 6x equals 4. And oh brother, because of this, I have a quadratic equation, right? So that should be an equal sign there. So that means that I should get everything over to one side and 0 on the other side. In other words, I need to set this thing equal to 0. So that means that I just need to subtract 4 from both sides, right? I need to subtract this 4 from both sides. So that'll give me x. If I subtract 4, minus 6 plus x squared minus 6x equals 0, right? And I still have some like terms and stuff I need to combine. So I'm going to go ahead and combine that and that, right? And remember, all I did was minus 4 here, and I went and subtracted 4 there. That's how I got this 6. So x squared, and when I add these, I wind up with negative 5x minus 6 equals 0. I would love to solve this thing by factoring. So I'm going to solve by factoring. So two numbers that if I multiply them, I get negative 6, and if I add them, I get negative 5. Well, that would be negative 6 and positive 1, which means that now for this one, I have two solutions. X equals 6 and x equals negative 1. I need to go back and check to see, will any of these give me 0 if I plug them back in, right? So if I plug x minus 1 in here, I'm good to go, right? But if I plugged that 6 in there, I would wind up with 1 over 0. So we have to say that this guy right here is an extraneous solution. And thus, even though we found two solutions, this is our only solution. So this is the only solution. All right, well, thanks so much for watching.
Welcome.
Welcome. Did Scotty bring you? Man, Scotty's always bringing people in the... God darn. I gotta go.